So here we're just practicing our derivatives. So when we differentiate these expressions, we want to use our product rule, chain rule, quotient rule. We could use a defined log base 3 derivative for log when the base is not e, but I would recommend to first start with changing the base of this using the log property. So we end up with 1 over log 3. And then we end up with log x times sine 2x. Okay, and in doing so, what ends up happening is the 1 over log 3 becomes a constant. So when we differentiate this, it makes it a little bit easier. So we're just going to keep that on the outside. We're going to differentiate using product rule. Okay, so I differentiate the first term, kept the second term the same, keep the first term the same, and then differentiate the second term. Okay, and here we have to apply chain rule because of that 2x. Okay, so now we have the derivative. We can simplify this a little bit. Really, there's no simplifying here. We're just going to rewrite this and organize this a little bit better. Okay, so we're not really simplifying, we're just organizing the terms. So we end up with 2 ln x cos 2x. Okay. This one we have product, we have chain rule, we have quotient rule. Okay, so we got a lot of things going on. So again, the first thing I'm going to do maybe is just to get rid of that extra log 3 here. So I'm going to rewrite this and change the base. And so my expression now is going to be x squared log x over sine 2x. And as I differentiate this, I need to make sure that I'm keeping track of the embeddedness of in this case I'm going to embed the product rule inside the chain rule. Okay, so as I differentiate this, keep the log on the outside, keep that separate. I'm going to differentiate the numerator. Okay, so I'm going to do the numerator in a different color. So I'm going to end up with 2x log x plus x squared 1 over x. Okay, so there's my product rule. And then I'm just going to do the denominator, sine x, plus, okay, now I've finished applying my product rule. I don't need product rule anymore, so I'm just going to leave that term, x squared ln x, the same. Now I'm going to differentiate the sine. Okay, this is sine 2x. So I'm going to differentiate the sine into cosine 2x, and then again apply chain rule on that. So maybe I'll put brackets in here, just make sure that show that that is not part of the inside of the function. Okay, and then I've now done so this is going to be minus because that's going to be the quotient rule. Okay, so here's my product rule here. Here's the numerator of the quotient rule. The quotient rule involves squaring the denominator and not doing anything to that. Okay, so there's my derivative. In this case, there's a couple little things we can simplify. Again, we can simplify this term here. We can reorganize the terms here. We can factor the 2 out. Actually, we can't factor the 2 out, so that's about all we can do. So I'm just going to leave it like that because that's probably good enough. I could, apart from simplifying that term to just x instead of x squared divided by x, that would probably be about all we would do there. So for this one here, we have product rule and we have chain rule when we have an embedded function in the exponent. So as I differentiate this, I'm going to differentiate the x and leave e to the x squared alone plus x times the derivative of e to the x is just e to the x, and then apply the chain rule, differentiate the inside into 2x. Okay, and again, there's not much we can do to simplify this. Okay, if you want, if you group this as 2x and differentiate that way, it doesn't matter, you'll end up with the same result, but it's much easier to factor out your constants. So I end up with e to the x squared, which is a common factor, and I'm going to have plus 2x squared. Okay, the x times x gives me my x squared, and that's about all I can do. So here again I have this exact same problem really. It's a product and embedded function, so chain rule. So when I differentiate this, I'm going to differentiate my first term and leave my second term alone, plus this first term undifferentiated. Now I differentiate the second term, so it just stays the same, but then because there's a function embedded in the exponent, I have to differentiate the exponent. Please don't differentiate the inside at the same time as the outside. Okay, so there it is. There's my derivative. Again, there's not much I can do to simplify this. There is a common factor of e to the sine x, which I'll take out, and I end up with secant squared x plus, here tan times cos, I can rewrite that as sine, because a cosine in the denominator of tan does cancel out. Okay.